Welcome back, ladies and gentlemen. This is Dr. Robinson again, and we're going to continue our studies on rational word problems. This time we are dealing with perimeter. We finished menu a little while ago. Now it's time to go on to perimeter. Now you should know perimeter is the distance around the figure. So here we have a question about Miss Silverman is making an ice hockey ring for her son and needs to purchase boards to go around it. So there's the ice hockey ring, and we're going around this figure. So perimeter is the distance around the figure. The hockey rink consists of two semicircles. That's semi means half, and we're talking about circles, so half a circle. So that's this rounded part here, and this rounded part here. So we have two of them, and a rectangle. So there's our rectangle there. The boards are sold in 6-foot pieces. That's important to know. Each board costs $10.50. What is the total cost? All right, so as I said, the perimeter of a rectangle is found by adding up all the sides of the rectangle. So perimeter is distance around the figure. So if we were going around this hockey rink, the first thing I see, I'd have to go around the rectangle. So the rectangle would be straight, whereas the semicircle parts are rounded. So I'm going to go around just the straight part of this rink, and that would be this part, which is 32 feet, as well as this part out here, which is also 32 feet. So the rectangular boards I would need would be 32 plus 32, which would be a total of 64 feet. So that would be the total of just going around the rectangle. But I also have to go around the semicircle over here as well as the other semicircle here. So I have two semicircles, and two half circles would give me one whole circle. So since I'm going around a whole circle, when we go around a circle, we don't call that perimeter, we call that circumference. So check out my video on circles so you can get a little bit more detail. So the circumference formula of a circle is pi times diameter, pi d. So we need to find the diameter, which is the line that goes from one edge of a circle to the other edge of the circle, and it cuts the circle into two equal parts. So this 20 feet would be the diameter. It's also the edge of the rectangle. So notice it's on the inside, and if you take a look at my video about inside numbers, we're talking about area. So the boards are going around, not on the inside. So that way, this line is not going to come into play for the rectangle, but it comes into play for the semicircle. So the distance from this point of the rectangle or semicircle to this point here is 20 feet. So that would be our diameter. So for the circular board, pi times diameter, pi button on your calculator times diameter would be pi times 20. That would give us 62.83185.307, which is approximately 63 feet if we round it off to the nearest whole foot. So now we know she needs 64 feet for the rectangle. For this distance around the circle, she needs 63 feet to go around both of these circles. That would be the whole circle, both semicircles. So she needs 63 feet. So she needs a total of 64 plus 63 feet, which would give us a total of 127 feet is what she needs. So the number of boards she needs, we're going to divide it by 6. Dr. Robinson, why did you divide by 6? Well, if you remember up in the question, let's go back up there. It says the boards are sold in 6-foot pieces. So they're not going to require 127 pieces because they're sold in 6-foot pieces. She needs 127 feet, but they're sold in 6 feet pieces. So the board is really long, and she needs 127, and they're selling them 6 at a time. So if we divide this 127 by 6, she'll really need 21 and 1/6 boards. So since she's going to need 21 and 1/6. We don't cut off the 1/6 and just say she only needs 21 boards, because she needs a little bit more than 21 boards. So we'll buy an extra board, which is 22 boards approximately, and that will give us the amount of boards that she needs. So now, if you remember the cost of the board, I believe it was $10.50. So we're going to multiply the 22 boards that she needs times $10.50. That'll give us her total amount she would have to pay is $231 for the boards to go around the rink for her son. So that was a dynamite question, had a lot of meat to it, so I hope you understood it. So here's a question for you to try, see if you can get it. Luciana is hanging up Halloween lights around the window of her bedroom, of her room. Uh, Her window consists of a rectangle and a semicircle. Oh, this time just one semicircle, not two. Each package of lights measures 48 inches and costs $4.55. What's the total cost of her lights? So notice, like we did before in the other question, we're going around the figure. So take a look at what we did before, see if that can help you out in dealing with this question. So I hope you found this video enjoyable and helpful to you. If you're not sure about how things went down, rewatch the video again. It was pretty good, and it had a lot of meat to it. So write down your questions, bring them into class, and I'll be glad to answer them for you. So our next video we're going to be dealing with will be area. So I hope you got something out of this video. This is Dr. Robinson signing off. Bye-bye.